All right, let's wrap up chapter 2. This is the third part of chapter 2. If you're just coming in here at the blue, you're in the wrong place. But anyway, so this is number 3 from chapter 2. So, what is software? Software, again, that's the invisible thing like music in a music system. You don't see it. So, there's two different kinds of software. The kind we are all using is called application software, like to do payroll or to play Spotify or to do a browser search. But behind the scenes, there's something called system software. That's your Windows, your iOS, your Unix. There's a bunch of system software or operating systems that work in the background and let the programs run, let you connect to things like the files, the printer, the devices you're storing data on. So systems programmers write system software and application programmers write application software. There's vastly more application software programmers than system software programmers. These guys typically come out of the computer science arena, and these guys can come out of the MIS or information systems area. It's almost two different kinds of people, seriously. We'll cover that more as the semester goes on. Oops. So, here, let me move on. Okay, so operating system, that's where, so Microsoft actually did not invent it, but they came up with what they had something called DOS, which now they have Windows, and Apple actually didn't invent theirs either. They both kind of stole them from Unix, sorry, from another company, which now created Unix. So kind of a long story, and that's what's in the movie called Pirates of Silicon Valley. But everything is based on the operating system working. We have to know what operating system we're going to use to write the applications. And different computers use different ones. Your iPhone uses a different operating system than an Android. They are different. They're similar, but they're different. So that provides the interface. How do we interact with the computer? And different programs use different things. It's just the operating system helps the efficiency, letting us use the resources. And so if you're a programmer or you want to write a neat program, you better know who's going to use it and therefore what kind of language you're going to write it in. Okay, so they do all the things like, again, job management. There's many, you could have 3 or 4 windows open at one time. Something has to manage that. So you use 3 different people send something in a network to the printer. Somebody has to manage that. Again, data, where is it being stored to? What physical devices is it being put at or coming from? And then how do you connect? How do you connect to a network or connect to the internet? So the operating system is what's doing all of this kind of thing. Then application software, like all the Microsoft Office we're using, word processing, desktop publishing, which we're not using, but spreadsheets, database, and all this, financial planning, accounting, payroll, CAD systems, project management, again, your Spotify's, your MapQuest, all that stuff is an application developed based on what operating system. So that's all software. You buy software, but you never see software. Now, software is all written in a language, so there's different generations of this. In the early days, it was very, very complicated. This is why it almost exclusively was mathematicians or people that knew physics who could write computer programs. It was very, very time consuming. They do run very, very fast, and sometimes you need to have the fastest program you can possibly get. Let me move on to the next one. So the second generation is a lot like the first one. So here at Grossmont College, we have CSIS 165. It's a required class if you want to get into San Diego State and study computer science. It's the CSIS 165 called machine level and assembly level language. It's the basic, really, what does a computer understand? It's dependent, each machine has its own language. So like IBM mainframes will have a different understanding than an Android. It's just different. So you have to use an in-between language. So it's easier than machine language, but it's still very, very, very time consuming. And sometimes that's worth it, like the earlier slide showed. You're trying to guide a missile or defend against a missile or something you need really to be fast. Maybe you will write it in one of these languages, which takes longer for the human than, for instance, the high level or the third generation, the fourth generation. This is where I started as a programmer with the third generation. Now HTML and COBOL and Pascal, a lot of languages were developed and humans can now read it. It was much, much easier for the human beings, but before these could get run on the computer, they had to be translated down to the second generation, down to the first generation. Fourth generation languages are pretty easy. Like when we use Access and create reports, we're going to be using a fourth generation language or a 4GL. And instead of saying a lot of programming codes, you just say, send it to the printer, poof, and you don't worry how it's doing it or what format. Let the Access or Excel format my report for me. These are the future. And even the fifth generation language, now we're using artificial intelligence. I mean, visual programming or just dragging something and grabbing it, kind of like the web tools we use at the end of the semester. It's just mind-boggling, amazingly easier. It's much harder for the computer, but as we know, computers are super fast and super accurate. So we really don't care anymore how hard it is for the computer because they're just mind-numbingly, well, beyond our comprehension fast. So this is what we're moving to. Artificial intelligence, um, and it's really cool. I am jealous of those studying computers now because I had to go through some of the hard times. So there's something called OOPS, object-oriented programming. And let me give you an example you can all understand. Let's say you're developing a website and you want to be able to take money, like a donate button. Well, today you don't have to write the program that will take money. You just plug it. It's called a plugin. You would plug in something that when you click this button, then you type in your bank account number and where you want the money to go and maybe minimum or maximum amounts or whatever. But then you go, poof, it's done. It's just like you would never write the software to put a map on your screen. You would just drag in Google Maps, or there's a whole bunch of tools. You would never write up the program to insert a video. You would just insert a video using YouTube. So there's lots of objects that already exist that you can just kind of click and drag and reuse them again and again and again. I'm not going to get into objects in classes because that comes in your programming classes. So again, this modular. So, you can just kind of drag them in as you need them, and you can reuse them for other purposes. I can have a like a credit card processing object that can be used in many different places. And see, another beautiful thing about this, you can program this in a relatively small size. It's only designed to process credit cards. They're not worried about where it is, and then someone just plugs it into the right, the right company that wants to use that at the time. And so I can help. It's easier to program and easier to debug because I can just work on one module or object, and I can just solve that and debug that and make that work, and then poof, other people can use it. It's really cool. And that's just when you start studying Java or C++ or Python, you're going to be using object-oriented programming. So in summary, there's lots of different things that a computer can do, from the palm of your hand to literally some people have them in their body, like heart, I forget what the name of those things that make your heart pump, to the huge ones that guides airplanes and naval payrolls, and all kinds of things like that. It's been evolving a lot, speed, accuracy, storage, and all they really do is math, compare, and store and retrieve. Input, process, output, and super, super, super fast. So, here you cover a little bit about chapter 2, what is system software, what is application software. So I recommend this is what you should do is, after watching this, browse through the book, and then when it comes time for quizzes and other exercises, you'll be well prepared. Okay, and it's totally up to you how much you're going to learn. I'll call that quits for now.